All right, here's a somewhat quick lesson on systems of equations. We talked about simple systems of equations today where it was just two variables and it was just x and y and you could use elimination or something like that. We didn't get into the tougher systems where you have either three or more variables like we have with this one, or what I'm going to do in a second, one like this where you have an x squared, and this is what we call a nonlinear system because x squared plus 1 graphs a parabola instead of a line. So I want to look at some problems like this. This first problem is going to take a while. These are kind of beastly problems, and there's really no quick way to do it short of just punching in your calculator, which I'll show you how to do that sometime later. But you need to know how to do these by hand. And to keep my work organized, because we're going to have stuff all over the place to solve this, I like to label everything. So I'm going to call my equations. I have three equations. I'm going to call them equations A, B, and C. And as I create new equations, we're just going to keep naming them D, E, F, G, however far we go. Looking at this, I like to use elimination. And so I'm looking at my variables, trying to decide what's going to be the easiest variable to eliminate. And you have several options, but what I see and what I'm going to do is looking at my y terms. If I multiply equation B by 2, then I will have a positive 2y to cancel with that negative 2y in equation A. So that's exactly what I'm going to do. I'm going to do equation A plus, and then I'm going to double equation B. And if I do that, equation A is x minus 2y plus 3z equals 7. And then 2b is going to be 4x plus 2y plus 2z equals 8. I'm just multiplying everything in equation B by 2, and we'll add those together. X plus 4x is 5x. My y's cancel, which was the idea. 3 plus 2 is 5z. So 5x plus 5z equals 15. And I just created a new equation, so I'm going to call that equation E. And I'll bring it up here. Equation E is going to be 5x plus 5z equals 15. So there's equation E. I've got to get another equation also. And once I've decided to start eliminating y's, I need to stick with eliminating y's. I don't want to change up and try to eliminate an x or a z. So now I'm looking and I want to eliminate a y in a different way. And one way I can eliminate y's is if you look at equations A and C, I have a 2y and I have a negative 2y and a positive 2y. Those are ready to cancel already, so I don't have to multiply or anything. I'm simply going to take A and add A to C. And if I add A and C, see, that's x minus 2y plus 3z equals 7. Negative 3x plus 2y minus 2z equals negative 10. So I have equations A and C. And when I add A and C, x minus 3x is negative 2x. Negative 2y plus 2y cancels. 3 minus 2z is a positive 1z equals 7 minus 10 is negative 3. And I just created a new equation, and I'm going to call that one, see, I have E. Where did D go? I never used D. Okay, so this one I called E. I'll call this one D. Since I skipped D earlier, I'll call this equation D. And D is going to be the equation negative 2x plus z equals negative 3. And so what I've done is I've created two equations. Now I've got equations with only x and z, and I pretty much start over, except I'm going to try to eliminate either x or z, and I'm going to solve these two equations just like the ones we did in class today. Looking at this, if I multiply equation D by negative 5, my z's will cancel. I have a positive 1z and a positive 5z. If I can do negative 5 times equation D, that's going to give me, see, negative 5 times negative 2 is positive 10x minus a 5z, and negative 5 times negative 3 is 15. And then I'm simply going to add that to equation E. And equation E is 5x plus 5z equals 15. We'll add those together. 10 plus 15, or 10 plus 5 is 15. The z's cancel. 15 plus 15 is 30. And then solve for x, you get x to be 2. And once you solve for one variable, the rest of them usually just start to fall into place. Now that I know what x is, I'm going to go back up here into either E or D, and I'm going to plug in 2. I'll plug it in right there for D. So I'll be negative 2 times x is 2 plus z is equal to negative 3. Negative 2 times 2 is negative 4. When you add 4 over, you get z to be 1. And now that I know x and z, I can go back to one of my original 3 equations, and I'll just choose b. Just choose one at random. It really doesn't matter. And I'll plug in my x and z there, which gives me 2 times x, but x is 2, so 2 times 2 plus y plus z, which is 1, is equal to 4. 4 plus 1 is 5, so y plus 5 is equal to 4, and you get y to be negative 1. So there's your solution, and you could write that as an order triple, and I'd say the final answer we'll say is my x coordinate of 2, a y coordinate of negative 1, and a z coordinate of positive 1. And so that would be my final solution. It's just like ones we did in class. You just take several more steps because you've got 3 variables and it takes longer to knock out the extras. Another one, this one is what I was calling earlier a nonlinear system. And nonlinear just means you're going to have a term to the second power or something along those lines that keeps it from graphing a line. So if I'm going to solve a system of nonlinear equations, you could use either elimination or substitution. This one is set up for substitution because I have y is equal to 4x plus 1. If I know that y is equal to 4x plus 1, then I could take 4x plus 1 and I could plug it in for y in this equation right here. And when I plug that in, I'll take out that y. I'm going to plug in 4x plus 1. I'll get 4x plus 1 for that y equals x squared plus 1. And I'll have an equation with one variable. We're going to solve this like algebra 1. I do see an x squared, which means I'm going to factor, and I like to have a positive squared term. So I'm going to move the 4x and the 1 over. Minus 4x minus 1. See, over here they cancel, give me 0 equals x squared. I have a minus 4x, and 1 minus 1 is 0. And we'll continue solving this by factoring. I'll take out an x. That'll give me x minus 4. And you get x to be 0 and x to be 4. And now we have 2 solutions, and we have to find the y that goes along with each one of these. So when x is 4, I'll come over here. If x is 4, we can plug it in anywhere. I'll plug it into x right here, and y is going to be 4 times 4. I'm sorry, that's 0. When x is 0, 4 times 0 is 0 plus 1, and you get y to be 1. So we have one solution. When x was 0, y was 1. My other solution, when x is 4, y is going to be 4 times 4. 4 times 4 is 16, plus 1. 16 plus 1 is 17. So when x was 4, I had a solution of 17. We actually have 2 solutions to that one, and that's usually going to happen with nonlinear systems. You'll get several different solutions. Let's see, how are we? 8 minutes. All right, we'll see if I can finish this up in a couple of minutes. Let's see, I have 2 more problems. Let's see if we can knock these out. This one, I'm going to go substitution. I'm going to, let's see, it really doesn't matter which one you do. On this bottom equation, I'm going to move the y over. That'll give me x is equal to 7 minus y. And now that I know what x is equal to 7 minus y, I can take 7 minus y and plug it into this equation up here. 7 minus y all squared. And then the rest of the equation is minus y squared equals 21. And to solve this one, you're going to have to FOIL this out. 7 minus y squared, that whole thing multiplies out to 49 minus 14y plus y squared minus a y squared is equal to 21. And this one gets kind of nice because y squared minus y squared cancels. That gets rid of your squared terms, which means we no longer have to solve by factoring. So 49 minus 14y equals 21. Subtract 49, you get negative 14y is equal to negative 28, and y is equal to 2. And then if y is equal to 2, you could plug it in anywhere and solve. I'm going to plug it into this bottom equation, although this is interesting. I'm going to plug 2 in right here, and I get x plus 2 is equal to 7, which means x is going to be 5. So there's a solution for this one. Never mind the interesting comment. So I have an x coordinate of 5 and a y coordinate of 2, and there's our solution. Yeah. There you go. All right, last one. 3x squared minus 2y squared equals negative 5. You can read it. This one, since I have a whole bunch of squared terms, this one sets up nicely for elimination because I'm looking at my squared term, my y squareds. And if I multiply the bottom equation by -1 or -2, then these are going to cancel. So that's the strategy I'm going to use here. I'm going to take this bottom equation, multiply -2 through, which will give me -4x squared plus 2y squared is equal to 4. My top equation, I'm going to leave it as is. 3x squared minus 2y squared equals -5. 3 minus 4 is -1, x squared. The y's cancel. 2 and -2 cancel. -5 plus 4 is -1. That means x squared is equal to +1. If you take the square root, which I'm okay with you taking the square root to solve this, but remember, if you take a square root to solve an equation, you have to remember that it's plus or minus 1. If you create the square root sign, you have to do the positive or negative square root. So I'm going to have to find my y's when x is 1, and then I'm going to have to find my y's when x is -1. So let's do x equals 1. Doesn't matter where you plug in. I'm going to plug into, I guess, this bottom one right here. So 2 times 1 squared, which is going to be 2, minus y squared is equal to -2. Negative y squared, subtract 2 over, you get -4. Y squared equals +4. Again, I'm going to take the square root to solve the equation, and you get y to be plus or minus 2. So when x is 1, y could be positive or -2, so that gives me one solution of 1 plus or minus 2. That's actually 2 solutions, 1, 2, and 1, -2. Same thing when I plug in -1. I'll plug in -1, 2 times -1 squared is +1. This would be 2 minus y squared equals -2. And this one's kind of neat because once I plugged in my -1, I got the exact same equation over here. So I'm going to go ahead and skip all that little extra step. I know that y is going to end up being plus or minus 2 here as well. The only difference is my x is -1. So my other solutions are -1 and plus or minus 2. So there we go. We'll hammer this out more in class tomorrow.